Good day everyone. In this video, we're going to talk about the DSS or Digital Signature Standard. So, what is DSS? As we have or as we studied, signature is a way of authenticating the data coming from the trusted individual. Similarly, digital signature is a way of authenticating digital data coming from a trusted sources. Digital Signature Standard or DSS is a Federal Information Processing Standard or FIPS, which define algorithm that use to generate digital signature with the help of secure hash algorithm or SHA. For the authentication of electronic documents, DSS only provides us with the digital signature function and not with any encryption or key exchanging strategies. Digital signature is a way to validate the authenticity and integrity of the message or digital electronic documents. Authenticity means to check whether the data is coming from a valid source or not to the receiver. This is to verify the identity of the sender, and integrity means to check that the data or message should not be altered during the transmission.
Use of DSS. The Digital Signature Standard is intended to be used in electronic funds transfer, software distribution, electronic mail, data storage, and application which require high data integrity assurance. The Digital Signature Standard can be implemented in software, hardware, or firmware.
Techopedia explains digital signature standards. The algorithm used behind the digital signature standard is known as the digital signature algorithm. The algorithm makes us of two large numbers which are calculated based on a unique algorithm which also considers parameters that determine the authenticity of the signature. The indirectly also helps in verifying the integrity of the data attached to the signature. The digital signatures can be generated only by the authorized person using their private keys, and the users or public can verify the signature with the help of the public key provided to them. However, one key difference between encryption and signature operation in the digital signature standard is the encryption is reversible, whereas the digital signature operation is not. Another fact about the digital signature standard is that it does not provide any compatibility with regards to key distribution or exchange of key. In other words, security of the digital signature standard largely depends on the secrecy of the private keys of the signatory. How DSS, Digital Signature Standard, work. The DSS is different from the fact that the RSA algorithm uses the public key, private key, and hash function, whereas the DSS uses the public key, private key, hash function, a random number key, and global public key. Therefore, DSS provides more security than RSA algorithm. As you can see, the picture here, there is a sender and receiver. A hash code is generated from the message and given as an input to the signature function on the sender side. The other input to a signature function includes a unique random number key for the signature, the private key of sender, PRA, the global key, this is PUG. The output of the signature function consists two components, sender and receiver, which is concatenated with input message and then sent to the receiver. Signature, sender, and receiver. At the receiver side, the hash code for the message sent is generated by the receiver by applying a hash function. The verification function is used for verifying the message and signature sent by sender. The verification function takes hash code, generated signature components, sender and receiver, the public key of sender, PUA, and global public key. The signature function is compared with the output of the verification function, and if both the values match, the signature is valid because valid signature can only be generated by the sender using its private key.
Steps involved in DSS. Generation of keys that is public and private keys for the source. Creation of digital signature by the source for a message. The receiver verifies the digital signature. 4 steps in how DSS algorithm work. As you can see, we have the 3 process. Find a prime number P, find another number Q, and compute. You only need to do the 3 process to complete this generation of global public key component.
Number 2. Finding the user private and public keys. Process. The private key X is any random number such that 0, X, and Q. The public key Y equals GX mod P. Number 3. Generating the signature. Process. Finding the components of signature S and R. R equals GK mod P mod Q. S equals K minus 1 HM plus XR. Mod Q where K is an integer such that 0, K, and Q. Signature equals R and S. Number 4. Verifying the signature. Process. Let M, R, and S be the message and signature components respectively received corresponding to M, R, and S. To verify the signature is valid or not, first the following condition needs to be checked. 0RQ and 0SQ. If any of the above conditions is not met, the signature is considered invalid and is therefore discarded. Otherwise, if both conditions are met, the following parameters are computed. V equals GU1 YU2 mod P mod Q. U1 equals HMW mod Q. U2 equals RW mod Q. W equals S minus 1 mod Q. Test V equals R. If V equals R, the signature is correct. Otherwise, the data or message has been altered.